Okay, this is Michael here again, and today we're going to talk a little bit about using a spreadsheet and how to use a spreadsheet more for scientific data analysis than other things for which it might be used. And the spreadsheet we're using is called LibreOffice Calc. A lot of people use Microsoft Office, which is fine if you already have it on the computer, but LibreOffice and OpenOffice are a couple of alternatives to Microsoft products that can be downloaded for free, and they work pretty good. In our laboratory and household, we use the free products rather than Microsoft. So let's first demonstrate how to get some data over into the spreadsheet from the Logger Lite program. And alright, so now we've got Logger Lite started, and let's go ahead and open the file that we saved on a previous occasion, just with the open, and we navigate over to the same directory we saved it in, which was the Vernier directory, and we recall the file called basketball bounce force. And if you recall, for that experiment we had the force plate out and we dropped the basketball a couple times from a given height on the force plate, and the force plate provided us with two peaks. So it's convenient, rather than saving as, say, a text file and then importing. I was playing with this earlier, and it's convenient to go ahead and to highlight, and you can do a cut and paste. It's a little easier than our earlier idea of importing the whole thing, because 10 seconds, 1,000 samples per second, that's 10,000 samples that you end up importing, and we're really only interested in the peaks. So this peak here starts at about 4.8 seconds and goes to 5 seconds. So let's zoom in so we can do our cutting and pasting of the data a little more zoomed in and focused on the actual peak. So if you come over here in the Logger Lite and you select it, you sort of pick a spot before the peak starts and make sure you run the spot, the highlighting, to after the peak has gone back down to 0. And you can see that it doesn't just highlight it in the graph, it highlights it over here in the window where you see the raw data. And so if you right click and you copy, essentially what has happened is it's copied those two columns now into the clipboard of Windows. And now if you go over and we have the spreadsheet running, so we just click over to the spreadsheet and you can paste the data into the spreadsheet. And in this application it gives you, it sort of thinks about it, and it says, okay, you're pasting some text, but how do you want us to understand it? So it has properly interpreted that we want the first column in the first column of the spreadsheet and the second one in the second column of the spreadsheet, because it's tabbed delimited data. And sometimes you might need to play, you can have comma delimited data, in which case you click on that to have it understand it, semicolon delimited data, space delimited data, different ways that one column can be separated from another, and this is how you tell it what's separating the columns. Now I've got this zoomed in a little bit, so hopefully you can see all the numbers really well. So you can see that this is the time column, 4.905 seconds, and this is the force column in newtons. And if you notice, I pasted it into the second row, because I always like to take care and label my column headings with the quantity that's in the column as well as the units. So the quantity that's in column A is the time, and the units are in seconds, and the quantity that's in column B, that's the force that the force plate measured, and the units are in newtons. And if you have enough room, you can spell that out, newtons, or you can just use a symbol like an uppercase. And let's go ahead and keep it like that. So this is just cutting and pasting the data into a spreadsheet, And I like to save spreadsheets early and often. Computers crash, stuff happens, lots of possibilities if you're not careful with your data. So I save it early and often every time I do some quantity of work I don't want to have to do again. So let's call this basketball, bounce, and now it's a spreadsheet, and there's some other files in there with a similar name. And let's just think ahead a little bit, because in a lot of experimental designs, an experiment gets performed a few times. So I usually like to denote that in the tab. If you notice, the spreadsheet here has several tabs, and it's called like sheet 1, sheet 2, sheet 3, and they're all in the same file. So why don't we call sheet 1, well, let's rename it, and let's call it bounce 1, or you could call it drop 1, or trial 1, or test 1. The idea in naming the sheet is simply that you want to be able to distinguish it from the other trials that may have been done in an experiment. So here we are back in the Logger Lite, and what we're going to do now is we're going to demonstrate again, except we're going to cut and paste the second peak, which corresponds to the second bounce of the basketball. So now we're back where we started. So this second peak is sort of between 6.9 and 7.1. So let's go ahead, and to zoom in on it, we got to go from 6.9 to 7.1. And that's just the range of times that basketball bounce occurred, between 6.9 seconds and actually 7 seconds, and then there's some noise because we did the experiment on the table. Alright, so we're only really interested in the force, the impact, and not the shaking of the apparatus after that. So now we've got it highlighted. Come back over here, make sure it's got the data we really want in it, and let's copy that data from the Logger Lite. And now let's go back over to the spreadsheet, and we don't want to put this in the tab that's called bounce 1. Let's go over here to sheet 2, and let's copy it, and you can do paste to copy it in. Once again, we get this little text import box because it sees we're pasting a lot of text, and it wants us to give us some information on how to organize it into the cells, and it recognizes that it's tab delimited. First column is time, units are seconds, second column is force, units are newtons, and so now we have documented what's going on here. And let's go ahead and rename the sheet, and we're going to call this one bounce 2 or drop 2 or test 2. We just try and pick a naming convention that makes some sense. You know, for example, if our experimental design called upon us to repeat the drop 5 times, we might end up with 5 sheets down here at the bottom. Bounce 1, bounce 2, and then sheet 3 we'd rename bounce 3, and so on. And you can hit this button here, and it will make as many extra sheets as you need, and you keep renaming them and cutting in the pasting of the data and so on. Alright, so what might we want to know about these different columns? Well, one thing that's probably of interest is the maximum force during that event. In other words, that's the peak force during the drop event. And this is important for a lot of things, because a lot of times the peak force on an object determines whether or not it's going to break, and that might be interesting. So, and this is just an example of a spreadsheet function. If you hit E equals, the equal sign, and then you type max, and spreadsheets think in terms of elements. The first element in that column is B2, And why B2? Well, in the element B1, we wrote force and newtons because we wanted that column to have a column heading to tell us what that was about. So the first element is B2. Then coming all the way down, the last element is B23. So if we type in the formula equals max B2 colon, actually that should have been B23. I'm going to type that in again from the start. Max B2 B23. That will tell the spreadsheet, hey, look closely at all those numbers and tell me which one's the biggest. Now, it's not of particular interest for this experiment, but somebody might care. What's the minimum value in that same column, B2 to B23? So we input the min, B2 to B23, and it tells us the smallest value. What else might you need to know from a column of numbers? You might want to know the average. And as you probably guessed, if you type in equals average, B2, B23, next thing you know, it averages them in the usual arithmetic mean kind of a way and gives you that. All right. Now there are some other spreadsheet formulas that you may need to come into play on a simple experiment, and one of those is called standard deviation, STDEV, and you can look up on Wikipedia standard deviation. It's an important mathematical computation that's often used, and what it is, it's the measure of the variation in a list of numbers. So if we go equals STDEV B2 B23, it computes the standard deviation of all those numbers. And it turns out that the standard deviation is pretty big because there's a lot of variation in the numbers. The minimum is -46, the maximum's 681, so the standard deviation is 247. And then there's another number we often compute, which I call SEM, and that stands for standard error of the mean. And in terms of how we're analyzing the column of data here, really probably only the maximum value is most important at this point, and I'm just using this as an opportunity to demonstrate the other built-in functions into Excel. And the way you compute standard error of the mean is actually equal to the standard deviation, and we just got to put it in again, B2 to B23, and then it's divided by the square root, SQRT, of the count of the elements. Now that's probably the most complex formula. I don't know, they're one of the more complex formulas we're going to go over, but that's one of the ones you need a lot in elementary scientific kind of computations in a spreadsheet. So the standard error is 52 and change, and the formula's up there. Standard deviation of between B2 and B23, and then of the square root of the count. Alright, so if you wanted to, you can cut and paste formulas from one spreadsheet into another. You got to usually take a little care that you've got all the elements right. So we copied from starting in A24, and we're pasting into A24, and then double check that the formulas are the same, and that just saves a little having to retype all of the formulas once you've already typed them in once. Alright, what else might we want to do in a spreadsheet? Well, it turns out for this particular analysis, that another computation that's going to be of interest is called the area under the curve. In other words, in physics, sometimes it's not just the height of a curve that you measure that's important, but it might be the area under the curve from once it starts to go up till it comes back down and crosses 0. So let's talk about that. How would we compute the area under the curve? Well, let's go ahead and let's go back to bounce 1. Go all the way to the top, and let's make another column, and we'll call it area. And the area is going to have the units of the x-axis, which is seconds, times the units of the y-axis, which is newtons. So the area has units of newtons times seconds. And we consider the area, and we're estimating it here, but if you think about each little data point and drawing a rectangle under each little data point, and the width of each rectangle is the time difference between two samples, and the height of each rectangle is the height of the curve at that point, or the value of the force. So the area under one data point is equal to the x value of the next data point, which is in this case A3, so it's A3 minus A2, and then times the height of the data point, and the height of that data point is B2. So the area under just that point is arrived at with that computation, and you can see it there. And now we can cut and paste that formula. Control C copies, and then we can go ahead, and if you recall, I said we wanted to only compute the area till it went negative. So we paste that formula back in all the elements until it has gone negative. And then let's come down here. And now we're not doing min or max or like that anymore. Now we're going to do a sum, which is going to give us the total area. So add up all those individual areas. We enter formula equals sum. And now we're in column C, C2 to C. Let's go ahead and add it up all the way down to 23, because the ones that we don't want, we didn't paste the formula in. So the total area under the curve is 3.948, and the units are newtons times seconds. All right, now let's think about how we might use what we've done already to rather quickly repeat that computation in the next tab, which is bounce 2, control V. So the area is there, and we pasted the one formula that we need. Copy the formula again, paste it down until it goes negative, and then let's go ahead back to bounce 1. We already did all the work of entering that formula in. We don't have to enter it in again. You paste it, and now you can see that the area under the curve for bounce 2 was 4.142 Newton seconds, and the area under bounce 1 was 3.948 Newton seconds. And this will be useful when developing a physical model for the basketball bounce.